Hi, I'm Shawn Powers, and this is your Linux Plus Tech Tip of the Day. There's a bit of a throwback for the Linux Journal folks in the room. Today we are continuing on the Linux Plus objectives for the security section that we're on. Let's look at what we're covering today. Okay, again, this is to remind me more than anything else, we're just here to summarize the purpose and use of security best practices. It's really tempting for me to just go through these things and demonstrate and show how to configure each one, but that's really not the goal here. It would take us all week.
I'm gonna need you to go ahead and come in tomorrow. So if you could be here around 9, that would be great. Okay?
Well, basically what we're here to learn is why Linux hardening is so important. And it's because if you're going to have a public-facing system, you want to make sure that you're not exposing any vulnerable services or any obvious weaknesses to the public internet, because it will constantly be attacked. And so there are a bunch of things here. I'm just going to go through and explain each one, what they would mean to your system, and maybe we'll look at one or two of them. I don't know. We'll see along the way. But anyway, we have security scanning. Now, security scanning can mean a bunch of different things, but when you're hardening a system, it's a good idea to scan it. And that can mean using tools designed for pen testing, or it can just mean something like from the outside of where it's going to be exposed, you use a program like Nmap and just scan for open ports, or you can use, like I said, specialty tools designed for Nmap that look for not only exposed ports, but vulnerabilities in the versions of the software that is available. But in its most basic sense, using a system scan or an external scan is important because you want to make sure that you don't have any other servers running and listening that you don't need, which I know is a later bullet point later on. But it's just important for you to know what's exposed. And it's really important to scan not only from the outside where you're exposed to the internet, but also scan from your internal network, especially if it's not just like a closed environment. If there are people who are going to be on the same local network, you need to scan your server from inside as well to make sure that you're not exposing things to somebody who might be sneaking in. And yes, I did recently make a pen test exam for a previous employer, or a pen test course for a previous employer, so I'm a little bit on the hyper paranoid side of things, but it's important to know what's vulnerable from inside your network as well as outside, because a person from the outside could potentially get into the inside, and you don't want that that feeling of safety just because your firewall is stopping people from getting into your services. You want to actually harden the server itself against all the attacks that might be possible. And one of the, most hard, like basic metal level metal, not like metal, but like the bare metal way of securing a system and hardening a system is to use Secure Boot. Now, Secure Boot is a feature of UEFI, and UEFI we've talked about in this course or Linux Essentials or maybe both. UEFI is the replacement for BIOS, which used to be like the thing that before an operating system even started, same with UEFI. Before an operating system even starts, it is what initializes the hardware, and it's like the layer between the hardware and the operating system on a computer. But if there's a rootkit installed on an operating system, if your UEFI or your BIOS is not secure, it could overwrite that firmware. And before you even install an operating system, it could have malicious code. And so the idea behind Secure Boot is that it is digitally signed, and we covered signatures and encryption a couple of videos ago. It's digitally signed to make sure that it is it's verified that it's not malware, like it hasn't been compromised. And there's a little bit of frustration with Secure Boot because most systems have a set of keys built in, kind of like the certificate authority for websites, where like browsers build in all of those CAs so that they know who to trust. Well, UEFI hardware manufacturers have done the same thing, but unfortunately, the only keys are generally from Microsoft. And that was a real issue for Linux users because guess what? Microsoft doesn't necessarily support Linux. Now, thankfully, Microsoft has agreed to sign Linux kernel. So like if you install Fedora, you can use Secure Boot and it will put this little shim, this signed shim that guarantees, Secure Boot will work. And it's signed actually by Microsoft for the Linux kernel, which is really bizarre. And it's not all puppies and roses because they don't use their main key to sign it. They have like a third-party key. It's still a Microsoft key, but it's like their third-party other people key that they sign the Linux kernel shims with. And so some hardware manufacturers may only have the official Microsoft keys built in, like the Microsoft operating system keys, not the Microsoft third-party keys built into their UEFI. In that case, you can't install using Secure Boot, but thankfully in UEFI, you have to be able to turn off Secure Boot, which wasn't the case originally, but now all UEFI systems, you have the ability to turn off Secure Boot. So if it isn't signed or it doesn't support that third-party Microsoft signature, whatever, you can just turn off Secure Boot and install it just like the days of BIOS, but you do lose that security feature of Secure Boot. So love it or hate it, at least you know what you're getting into now when you're dealing with Secure Boot on a system. Next up is system logging configurations. And this could mean a bunch of different things, but it's important to understand how logging works. Now, we've covered some logging in this video and in other videos as well. There's even I'll try to remember to put like a link up there where I talk about like rotating logs if you haven't set that up. The thing about logging is you can log to a centralized server. Now, there's multiple reasons to do that. One, it's a one-stop shop for checking your logs. Two, it's great to have a place that logs get sent to in case something gets compromised or lost. Your logs are not stored on that compromised server. You can centralize where they go. There's also some like third-party DevOps tools that will help you with all of your logging and sort through things and identify problems. So centralized logging is generally a good thing, not just for convenience, but for security, because if it's on another server, generally it's not going to be deleted. If somebody logs in and they're like deleting all the logs so that, you don't see what's happening. If you have centralized logs, that isn't necessarily going to be the case. Setting the default UMASK. Now, if you're not familiar with UMASK, it is when you create a file, there's a default set of permissions, and that default set of permissions is determined by UMASK. Now, you can set UMASK immediately on your system, and it will change it's like an environment variable type of thing. I don't know if it's actually an environment variable. It probably is. That's how everything works in Linux. But you can set it for your local instance, and then when you log out or reboot, it'll reset to the system default. It's also possible to change the system-wide default. It's part of the PAM modules thing. You need to either change it there or like in etc. default UMASK or common. There's multiple places to change it system-wide. But again, this is not a how you do it video. This is a why you would want to do it video. The thing about UMASK is it sets the default permissions for files and folders that are created. I am going to show you what that means, but when you set a system-wide one, you can make things more secure out of the bat. So when a file is created, it's not accessible by everyone. You can really lock it down if you want to make sure that all new files are very, very secure by default. Okay, so I'm here on an Ubuntu system, and if you just type UMASK, it's going to show you the current default UMASK on a system, and it's 0002. What that means is if we were to touch a file, so touch test file, and then do ls-l, it's going to create it with read, write, read, write, read. If we create a folder, it'll be a little bit easier to see what the UMASK is doing. So make directory test folder. And here you'll see it's read, write, execute, read, write, execute, read, execute. And basically it takes the octal notation of this. Let's say it takes the octal notation of 777 and it would subtract the 2 from it. So what that would mean is our default would be 775, which if you do the permission string, that's what this is. 7, 7, and then 4 plus 1 is 5. Yeah, check out the permissions video earlier on if this is really confusing, but it's using octal notation to figure this out. So basically, UMASK says, okay, with all the bits turned on, if we subtract this, that's what the default's going to be. But for a file, it doesn't make it executable. That's just the default. It doesn't make it executable. But let's say we made our UMASK 0022. And now we touch test file 2, ls-l. You'll see the difference here. Test file 2 now has the right bit off because it subtracted that 2, because now if we do UMASK, we'll see it's 0022. And so it removed that from that bit. If we did UMASK 0027, and now we touch test 3, ls-l. Now we're going to see the other has absolutely no permissions on this because we set that UMASK to 7 for the last bit, and it subtracted all 7 bits, and so it's left with nothing, and boom, there we have. There's nothing there. So UMASK is just a way that it takes permissions away from when a file is created. And again, there's a couple of ways that you can set this system-wide. It's going to differ for every distribution a little bit, but it's part of the PAM, Pluggable Authentication Modules system, that generally is where you would set that up. But again, this isn't a how-to. This is just a why you would want to do that. This next section, disabling or removing insecure services. Now, even if they're not insecure, things that aren't used should not be enabled. Now, obviously, if they're insecure, well, I don't know why they even exist in the system. I mean, I guess you don't want to have a telnet session exposed. Somebody might use it and that, just uses plain text. So anyway, but disabling or removing insecure services is talking about using like systemctl, which again, we've covered a little bit before, and doing disable for a particular service that you don't need running on the computer. If you don't need it running, there's no reason to have it running and expose that. Even if it's a very secure service, you don't want to have it exposed so somebody could try to take advantage of that. So if the server is not using a service, disable the service or uninstall it. If you're concerned that somebody might start it back up, just completely remove it from the system, apt-get remove or apt-get purge to get rid of that, because you don't want anything extra running on your server. That's just asking for somebody to, attack a new vector that you didn't even have to have there in the first place. Enforcing password strength. This is done again with the pluggable authentication modules. It's generally in etc, pam.d, common password or password common. You can specify like how long a password has to be, how complex it has to be. And sure, there are reasons that you don't want somebody's password to be 1, 2, 3, 4. But at the same time, a little story, put on your story cap or your night cap here for a story. When I was a young system administrator, I wanted our system to be as secure as possible. And so at the school district I worked at, I forced everyone to use very complex passwords. They had to be a minimum of 12 characters long. I had to have numbers, uppercase and lowercase, and, random other characters, etc., etc. And everybody had to do it. And I was very, very proud of myself until one day when I went up to central office where all of the paychecks are created and the school, like the superintendent's office was. I walked into the central office and I looked, and on everyone's monitor was a sticky note with a really complex password right there because they couldn't remember it and they wanted to have it so they could log in. So yes, you don't want people to be able to use really dumb short passwords, but if you force somebody to use a really complex password, they're going to put a sticky note on their monitor and all of your security plans are just out the window. So with great power comes great responsibility, and this is another one of those instances. Removing unused packages. This is pretty much just like the one up here, insecure services. Yeah. Don't have extra stuff installed on your system, because even if it's not a service running, there might be a program with a vulnerability that somebody who has access to the server could use as a vector for attacking. So again, don't have any, unnecessary services running or installed, and don't have any unnecessary packages installed, because everything can be a compromise to your system. And so the fewer things you have to worry about, the fewer things that can go wrong. So this is just another good idea to think through. What do I really have to have on this computer? Let's see, tuning kernel parameters. This can be a whole bunch of things. Like when you're setting up a server, you want to make sure that things like there's enough page files. That's something that a number of files that can be opened on a system. So you'll need to tweak kernel things. Like, for example, you don't want to have IP routing turned on if you're not doing IP routing between your interfaces. So tweak the kernel parameters that you need, and don't make changes that you don't need. Now, by default, most distributions are going to give you a sane kernel configuration out of the box. But just know that there might be things that you can tune, not just to harden your Linux box, but also to make it more performant. And a crashed system is a vulnerable system. So, while, yeah, we want to lock things down by hardening, we also want to make sure that it functions efficiently, and things like number of files that can be open on a system with the limits.conf file is something that you want to consider. Make sure your kernel is tuned for specifically what that server is going to be doing. Securing service accounts. Now, service accounts are things like when you have Apache 2 running, for example, and it's a web server, it doesn't run as the root user. It runs as www-data. And again, when you install it on a distribution, it generally has some pretty sane default settings, right? The password isn't enabled on that user. You can't, nobody's going to be able to log in with that user, but it's important to keep in mind that just because things are generally by default configured good out of the box, you should understand why those are configured that way. You don't want somebody to log into your system as www-data. That is a service account that is never meant to be logged in as. It's meant to only run that service, and it runs that service with the notion that nobody's going to become that user. Because if somebody could log in as that user on your system, they could wreak havoc anywhere that the web server has access to, that user would have access to. So you don't want that to be something that people can log in as. It might be tempting though, right? I mean, if all the files need to be owned by www-data, shouldn't I just log in as that user to create my files? No, you should not. Because again, it's a service account designed to run the service and not be an interactive account at all. Lastly, I touched on this a little bit at the very beginning, configuring the host firewall. And this is important because yes, your whole network will almost certainly have a firewall that is protecting you from outside people coming in, right? Only certain ports are opened and forwarded to your internal server. However, it's also best practice to have a firewall configured on the server itself, on the local machine that we're hardening. There should be a firewall, again, to protect you from people who might be trying to attack from the inside, but also just because having a firewall configured is just one less way that people can, attack your system. So have a firewall on your server, even if you have a firewall on your entire network. Don't think that just because your network is protected or, firewalled off from the internet, that doesn't mean that you don't need firewalls inside. Every server should have its firewall enabled and only open the ports that have to be opened on that firewall to, have remote access, even if that remote is inside your network. So again, that was just a list of security hardening things that the Linux Plus objectives wanted you to kind of be able to consider and think about when you're hardening a server with security in mind. But that doesn't cover everything. And I don't normally plug books and stuff, but this Linux Hardening and Hostile Networks is written by my friend Kyle Rankin, who I've talked about before. I purchased this book myself with my own money. That's my own coffee stains on it. I've used this book. I used it when I set up my mail server that I'm running postfix. I used Kyle's book to make sure that I was doing smart things as I set it up and exposed it to the network, et cetera, et cetera. So this is a really, really good book, and I'm plugging it, yes, because he's my friend, but also this is the best book I know on practical guide to hardening a Linux system. I'll put a link in the description as well if you want to order it. Like I said, I bought this myself. It's not like a signed copy. It's not something that Kyle just sent to me because he's a friend. But yeah, it's awesome. You want to check this out. This will yeah, it'll help you pass the Linux Plus exam objectives, but also it will make you a much better and security-minded system administrator. Anyway, I hope you're still here. I know this was a less hands-on type of video than we normally do, but it's important to think through all of these security things. And speaking of sticking through, thank you to my Patreon supporters who continue to stick with me month after month. Y'all are awesome. Thank you so very much. I appreciate it. And it gives me incentive, but also gives me the ability to invest time making these videos and giving them away for everyone who may benefit from them. So thank you very much. And with that, remember to learn everything, do what you love, and most importantly, be kind. Thank you, and I will see you at the next video. Oh yeah, check out the whole playlist thing right there. That's all the videos that we've been working on so far. So if you want to see more, that's where to go. Thanks again.